Okay, so here's 5.2b, logarithmic functions, properties of logarithms, and we are in example 5, evaluating base 10 logarithms. Now remember what I said, if we don't put the base on a logarithm, we assume that it's on base 10. Okay, so on example 10, they give us, or example 5, they give us this, and they want us to find if x is 10,000. So that would be log of 10,000. Okay, so what exponent goes on 10, the base here that we don't show, that will give me 10,000. And that should be 4. 10 to the 4th power, and this is in exponential form, gives me 10,000. So in logarithmic form, it would look like that. All right, so let's keep going here, and let's move to example 6, where we're dealing with pHs. Now, if you've done anything with chemistry or science, you have studied pH, gives you a little bit of information there on pH there, but the key part here is the formula for pH. So P, lowercase p, capital H, is negative log with a base of 10 with a hydrogen ion there. Okay? So, don't really need to know the chemistry, just need to be able to do the math. All right? So, a pH of, all right, pH goes from 0 to 14. Okay? pH of 7 is neutral, less than 7 is acidic, and greater than 7 is a base or basic. Okay, so acids, dishwashing, everything has a pH bound or a pH level. All right, so for example, A, it says, using table 5.6, find the pH level of bleach. Well, we go down there and we look at bleach, and we find out that bleach has a pH concentration of hydrogen ions of 10 to the negative 13, and that is our number that we put in for that. So negative log of 10 to the negative 13. Okay? So all we're going to do is plug that into our calculator, and we're going to get the number 13. Okay? And you do that for lemon juice and C. Bringing us to example number 7. Example number 7 is an opportunity for you to explain how the graph of each of the following functions compares with the graph of log of x, and find the domain and graph. So what we're going to do is just kind of get an idea of what's going on here. A, y equals the log. That 3 there tells us that if we had y equals log of x and we are comparing it with this, we added 3 to the x, which means we shift it 3 units to the left. Okay? If we're on B and we have y equals 4 plus the log, and this is going to do several different things. This negative 2 means that we're going to shift it 2 units to the right. This 4 means we're going to shift it 4 units up. Okay? The vertical asymptote on this, where it never crosses, is at 2. And the domain is from 2 to infinity. Which again, the domain is what numbers can I plug in for x that will still make this a true statement. What are my possible numbers? Not 0, not 1, but it starts at 2 and goes all the way to infinity. In fact, it doesn't even include 2. 2 is the vertical asymptote, meaning it never crosses 2. So it's any number bigger than 2. Okay? Not necessarily starting at 3. Could start at 2.0000001. Okay, as long as it's bigger than 2, it works. And when you look at number or letter C, what happens there with 1/3? Well, it compresses because it's 1/3. If you remember from, gosh, it was a table back earlier that we had looked at. Maybe it was in 5.1. I don't remember off the top of my head. All right, so let's jump into natural logarithms and go from there. All right, so far we've done common logarithms, which looks like that. A natural logarithm is ln. Easy to remember because the n stands for natural. And we had talked about e earlier, being 2.71828, whatever it was. Well, this is the inverse of that, just like this is the inverse of our other exponents with a base of 10. Okay, so if we have a log with a base of e like that, that gets to be kind of a pain to write because it's very similar to a base of 10, like that. Okay, so this is a common logarithm, this is a natural logarithm. But instead of writing this, they've come up with a shortcut, ln. Okay, so these two are the exact same thing. This is just a shortcut way of writing this, okay, showing that our base is e rather than 10. And those are the two that we're going to deal with pretty much more than anything else. Base of 10 and a base of e. Okay, some of the formulas are going to want you to have that base of e. Okay, so I'm going to skip example 8. You can look at that. It's pretty self-explanatory, not really too terribly difficult. But I want to get into the logarithmic properties. And that is what we've got there in the middle of page 335. And we're just going to use some examples there in example 9 and look back in how we solved these using that little green box there. So we've got log with a base of 5, 5 with a 10 as an exponent. And if you want to solve that, you look up at the top, or in the basic properties of logarithms, and you look for one similar to that. The one similar to that is, C, number 3. Okay, so when we have something like this, the exponent is the answer. The exponent is the answer. So the answer is 10. We get into B. So B is log with a base 4 of 4. And then what you're going to do on B is you're going to look at the properties up there and find which one is similar, and you find the first one, and that equals 1. So therefore you know that this equals 1. All right, so let's look at what happens here. I mean, I'm just telling you it's 1 based on this, but let's see where that comes from. Let's move this into exponential form, and maybe that'll be easier. 4 to the first power equals 4. That's a true statement. 4 to the first power always equals itself. And that's basically what this is saying. Okay, so if you look at A, B, C, D, E, and F in example 9, that should give you some real help on just being able to finagle those around. And I would write those down because you'll probably be happy you have those when you come to a test and I ask you questions on those. All right, so rewriting logarithms. And this is important stuff. May not seem important now, but later on when you're doing some of these and you're like, what the heck do I do here? If you know how to rewrite them, they're easier to solve. Now you look at that and it's like, oh my gosh, there's no way I can figure that out. Well, you can use additional logarithmic properties, top of page 336. And so for this one, we're going to use property 6, which says if I have a logarithm with a base b where I have 2 parts multiplied, this part and this part are multiplied. what do? I take the log of the first one. What am I doing here? 5 plus the log, same base, of the second one. Okay, and that would be my rewriting. What it does is it simplifies it. It doesn't look like it simplifies it. It looks like it makes it more complicated, but actually it does simplify it. All right, so let's look at C. I'm going to let you do B by yourself, or at least look at it. And this is x minus 8 over x. And looking at property 7 with division, I'm going to take the log of x minus 8, base is 10, because I don't need to, I'm not writing it down. It doesn't appear, so you assume it's true. And I just take the top number minus the bottom number. Top number, okay, here it is, minus the bottom number. All right, so anyway, you follow those for example 10. And we get to 11. Kind of looking ahead here. See, I think I probably should start another video here right after we do example 11. See if I can keep from getting drowned out by the airplane that's getting ready to fly over. Log base 3 of x plus 4 log base 3 of y. Alright, so they want us to rewrite it as a single logarithm. They want us to go back. So what we're going to do is we're going to go and look at that additional logarithmic properties and go backwards. So I'm going to look at one that has additions, and then I'm going to see if I can move this back to something earlier. Okay, one of the things I've got here, I'm going to look at that number first. When I'm given something like this, I'm always going to look at the number in front of the logarithm because that is an exponent. So I'm going to try to get rid of that first. And that goes up there on the y. Okay, and that's from number 8, the power property. Okay, so now I don't have any numbers in front of my logarithms, and that's the first thing you're going to do. Now I'm going to look at property 6, and I notice that they're added in property 6 and they're added there. So what do? I give my same base and I scrunch them together. And it says here, when you have an answer that's added, in order to put them together, you multiply. So I take that and that, let me do it in red, that and that, and put them together in multiplication. So I'm kind of going backwards, kind of in the reverse direction. All right, so let's look at B. And I've got 1/2 log of A minus 3 log of the B there. Okay, so again, I'm going to do this first. And get rid of that 3. Okay, by doing that. Now I've got a minus, and the minus, if you remember, from property 7 is a division. So then I'm going to rewrite this as the log with no base, because the base is 10, it's not showing up there. And I'm going to take my a to the 1/2 and put it on top and put it over b cubed, put it in parentheses, and that is what I get there for B. And I do the same thing for C. Again, that's another division one. Okay, so I will close out 5.2b and start with 5.2c.